Hello, everyone. Warm welcome to our machine learning session. I am here in front of you to explain one module, which is like TensorFlow. So today we are going to create a model using TensorFlow library and how TensorFlow is going to help you and provide accuracy of a machine learning model. Let's quickly get started and let's explore. So in today's session, it is completely dependent how you are going to create a mini machine learning model using TensorFlow. TensorFlow is directly linked with deep learning. Today, we'll explore the role of TensorFlow in building a machine learning model that predicts if a person has diabetes or not. This is a beginner friendly walkthrough and I'll explain each and every concept with simple using real world analogies, and we will be understanding the role of TensorFlow in binary classification using neural network. So I hope you all are excited and we'll be starting this. First of all, let's understand what is a TensorFlow. So basically, when we talk about TensorFlow, think of TensorFlow as a very smart cooking assistant. You all love cooking, right? Or if not, you must be foodie or you love to eat or explore different kinds of food, right? So you give it a recipe, right? Your model structure is actually a recipe. The ingredients are your data, and it helps you to cook the perfect dish. Means basically the trained model. It is an open source library which is developed by Google, and it's like the engine under the hood that powers many intelligent apps like voice assistants, spam filters, or even health predictions. So when you talk about TensorFlow, it's a library which is going to help you to get into the deeper insights. Basically, it's a deep learning model which helps you to build and train. So when you are talking about like how you are going to build, what are the things which you are going to take care, it is going to take care of each and everything. It provides you a structure. You just needed to use this library, provide what sort of outcome you are going to see and you are thinking exactly in the same manner it is going to provide. For example, I have already shared it with you that you can create voice assistants, you can create spam filters, or even health predictions. So all these things you can do by using this simple library that is called TensorFlow. If you remember, when we started this machine learning course, you have put your hands on practice on teachable machine, right? So in teachable machine, when you are exporting your model is exporting either with TensorFlow Lite, TensorFlow.js. Please go back and see the all these image recognition, posture recognition, or audio projects. These are all being created by using this library, which is called TensorFlow. I hope till now you get like little bit of idea how TensorFlow works, and it widely used the neural network based classifications and regression tasks. And that's why that makes it more important. And Google has taken care of each and every aspect of it, how this library is going to work around. So let's quickly understand what project we are going to create and basically what are the project objectives which we are going to get started today. Today, we will be starting a very simple or mini project as it has already shared with you that we are going to create a diabetic related ML model, which is going to help you to find out whether the person is diabetic or not. And that we are going to use in very simple way. It's a very simple model and let's think about it and let's create it. Okay. So let's understand the project objective. So basically imagine you are a doctor with hundreds of patient records with you. Age you must have, because whenever you are getting or for the checkup, if you are visiting, doctor takes these kind of details from you. It includes age, it includes your BMI, which is body mass index, It includes your glucose level. Wouldn't it be great if a tool like this, which you are going to create, a machine learning tool, is available for you that could help you identify which patient are at a risk of diabetes or which are free from it. And that's why it becomes very, very important, the project or the project which you are creating. And that's why we are doing it here, so that when you are writing in your resume, you can write that this is a real time project which you have created considering the society. All right. And we are building a model that looks at health data and tells us, yes, this person is at risk, and whether that person is free from diabetes, they are not. In fact, you can consider it in a manner. Whether this person has diabetes, instead, you can take some more data and you can analyze some more health risks also, which are nowadays very skeptical, which we usually don't think. And people are at that risk, right? So these are certain things which you can get started with. And TensorFlow is going to help you to build that logic using artificial intelligence. So let's quickly get started and let's understand how you are going to build the model. So basically, we are entering into building that model to understand the significance of each and every part of it. So basically, in the same way, our brain has layers. Like, let me quickly share with you how you are going to understand it in a manner. Basically, when we talk about deep learning, it has different layers. The first layer is called input layer, in which you are going to share the input, which includes the data and the information, whether you are talking about age, BMI, glucose levels, all these are data inputs. When these data inputs are going to enter into the first layer, these layers are basically process information from seeing to thinking and deciding. A neural network does the same thing the way your brain works. Because when we want to drink water, right? Our muscles, our mouth, our body needs actually send that signal to the neurons which are present in our body, and that is being received by our brain because all these neurons are interlinked. All right, and in different layers it works. Similarly, copying that, there is a neural network which does the same. In TensorFlow, we use dense layers to mimic brain neurons. The way our brain works, similar way, these dense layers, these mimic the brain neurons. And if we are going to add ReLU, which we have used previously also, it allows complex decisions like should I turn right or left. These kind of decisions makes very, very important. Along with it, there is sigmoid to make a final yes or no decision. So when we are creating this model and we are going to use sigmoid, it is going to give us an answer like whether this person is diabetic, which is yes or no, whether this person is not a diabetic person, like turning on a light switch. Or you can say dropout is like occasionally covering your eyes to force your senses. It helps the model to avoid overfitting. So overfitting and underfitting is basically like when you overtrain and model fails. In both the condition, whether it is overfitting or underfitting, model usually get fails. We will be understanding this concept little later. As of now, to understand that these layers, which dropout layer, it prevents overfitting by randomly disabling neurons, right? And when we talk about activation functions, it introduces non-linearity by using ReLU and sigmoid. When we talk about dense layer, that is the exact feature which we will be using TensorFlow, which is a part of, we are going to extract that from the Keras sequential API. So these are all things which with which you are going to build this model. I have given you a brief introduction about it, how you are going to get started, what exactly you are going to do with it. Let's understand it in depth. So, first of all, when we are talking about dense layer is basically exact feature that is going to mimic human brain neurons. We do have neurons. If I wanted to move my hand at top, it is exactly that I am sending my neuromuscular coordination is sending that signal that I needed to raise my hand. Similar feature is being taken care by ReLU, which allows complex decisions like should I turn my hand up or not? Should I take the left turn or the right turn? So these are the things which is being taken care by Relo. Now, when we talk about activation function that is introduced with non-linearity function that is being taken by sigmoid to make the final decision whether it's a yes or no, whether we should move forward or not, whether the person is diabetic or non-diabetic. So these are all being taken care by all these models which we are going to introduce over here. Last, which is dropout layer. Dropout layer basically tells you how you are going to go ahead with it. Right now, let's understand what is underfitting and what is overfitting. So, basically, when we are talking about overfitting and underfitting both makes the you can say machine learning model failed. So, let's understand what is this. So, when we talk about overfitting is nothing. These are basically the models where overfitting the model learns too much from the training data, including the noise which was not necessary, right, or irrelevant pattern. It performs very well on training data but poorly on the testing data. All right, maybe the data which we have provided, it was not it is being taken or selected from ad hoc basis, and the data which it got, it was like way different from the testing data. So that is one of the case of overfitting. To avoid that, we use these outbox or you can say the layer which is your dropout layer. So it actually disable the neurons which takes the data such as noises or irrelevant data. Now let's talk about underfitting data. The model learns too little, missing important patterns or information. It performs poorly on both data training and testing. So that is underfitting. So when we talk about real world analogies of it, let's understand the parrot student. Imagine you are a student who memorizes each and every word from the textbook, right? Including spellings, which includes mistakes and side notes, but doesn't understand the concept, which we used to do when we were kids, right? In exams, if the question is slightly different, or if, the meaning of the question is same, but it is the language or it is being written in a different way, then students get confused and answer incorrectly. That is called overfitting, right? You have taken each, like, is this going to come like this? If this word is coming, then I'm going to write this answer. So that is absolutely overfitting. When we talk about underfitting, it's like a lazy student. Now imagine a student who just skimmed through the book. They don't learn much, they just answer even the basic question in the exam they were not able to answer. So underfitting is low and the accuracy is also low. Wherever when we talk about overfitting, the accuracy in the training data is very high, but the testing data is low. So good fit is when the training data accuracy is high as well as the testing data accuracy is also high. That is called overfitting and underfitting. Let's understand how you are going to detect it. When it's overfitting, high training accuracy, low test accuracy, and the fix which you are going to do for that, you are going to reduce model complexity by using dropout regulation. And if you want, you can add some more data also. More data is going to help you to provide better accuracy, as I have already shared. Now, how you are going to fix underfitting, which has low training and low testing, it means you are going to use more features deeper model or train for a longer period of time. So that is what you can do. So underfit, overfit, or good fit. I have explained all these terms in front of you. Now let's quickly see how you are going to compile that model, because compilation is a very, very important task. So compiling is like configuring your car GPS before a road trip, right? You must be choosing your fuel efficacy or optimization, destiny, as well as you are going to see how to measure progress, how far you have reached. We use Adam Optimizer, which I have already introduced in the previous segment, for its balance of speed and accuracy. Binary cross entropy, because we are making a yes and no decision in our diabetic model. So therefore, we are going to use the accuracy to check how often we are right. And based on that perception, we will be coming across. So basically, when the first part is define how the model learns and how performance is measured. Optimizers we are going to use Adam optimizers to adjust weights efficiently in our neural network basis. Loss functions we are going to use by checking the binary cross entropy for binary classification. And for matrices, as you already know, that is going to track the correct prediction by using MAE or RSME, which we have been using in our previous models. So these are all things which you are going to do. Let's quickly move to the next one. Here you are going to understand how you are going to train the model. That is one of the steps which we are going to do, and most important step. Training is like teaching a child, right? You must have siblings at home, right? So from scratch, when you are teaching your model how it is going to give answers, what you are going to do, you show them many examples. This person has diabetes, and here are their health matrices, over 100 rounds of epochs. The model learns different patterns, that if this pattern shows, if this graph is like this edge is there, like just we have learned over years how to talk, right? What is an apple? So similar way, this machine is also going to learn small group of data, which is called batches. It helps it to learn efficiently without getting overwhelmed. It gets better and better with each round, right? If you are giving 100 rounds and every time a different kind of apple you are showing to your younger one, they are going to understand it in a better way, in a best way, I would say. So this is how a model learns. This is how a model is going to bring in the efficacy. And this is how the training gets done. So basically, when we talk about epochs, epochs is basically how many times you are training. And batches are basically, when you see in this slide that batch size is going to be 16, it means that 16 times, or in a batch of 16, it is being done. These 100 rounds are done. And it learns by minimize the loss function. Minimum loss function basically means that your accuracy is at par. In today's model, we are going to see how much accuracy you are going to bring in. All right, we are going to see in percentage that our model accuracy is this much. That is what we are going to bring in today's model. Let's quickly see how you are going to compile the entire information using TensorFlow and what exactly is going to be the role of TensorFlow in today's model. So moving to the next one, this is the last one, that is evaluation, and evaluation plays very, very important role. Basically, evaluation is one aspect once your model is trained. That is where our role comes and matrices comes. We test the model on new patients. It's like the model hasn't seen, just like a student final exam, which a student has not seen. All the questions are going to be like different, but obviously from what he has learned from the syllabus only. It's just like that. We check how well it predicts the diabetes of a person. Tools like confusion metrics tells us how many it got right and how many it got wrong. And this is what we are going to use ROC AUC score. So basically, it helps us to understand how well it separates people who have diabetes from those who don't have diabetes. This step is crucial to ensure we can trust the model in the real world. And that is what we will be doing so that you can surely and proudly mention this in your resume. And now let's quickly compile this entire model and quickly get started with our Google Colab with the coding aspect of it. So I hope you all are ready with your coding helper. That is your Google Colab. You can take the data from the resources and we are going to get started with it. First of all, I'm going to take you to go through the data so that you will understand what data you will be taking. However, I have kept the model very, very simple. The data set also I have kept very simple, in which I have taken 300 rows and only 5 columns. Out of 5 columns, 4 columns are basically the input column, which is multivariate, and the last column, which I have kept as output column. So this is how I have taken this data set. Now let's quickly summarize our model, how you are going to use the TensorFlow in this model. So basically, TensorFlow helped us to build a smart prediction engine. We are going to handle the structure of a brain-like network, train it, use maths and data, and give us the tool to test its performance. Whether we are going to use and provide this in the hospitals among doctors or not, or a kind of mobile app also you can create by using this particular model which you are going to create today. So I would request all the students, if you are into app creation, you can create an app and you can use it and you can share it on Google Play so that people who are diabetic, they can check their diabetes, or who are on urge of getting diabetes, they can also track and check the fitness. So it is going to be working as a fitness tracker app. TensorFlow makes AI development accessible and powerful, or that is exactly the work which we will be doing using TensorFlow. So let's quickly see what we have done in today's session. In today's session, we are going to create a model using TensorFlow. So what exactly TensorFlow? That is what we have learned, that it's a model which is a part of deep learning in which it is going to use human brain like structure to solve complex complexity and minimize the loss function. It helps us to create a better accuracy by using epochs as well as using sigmoid ReLU. All these are going to help us to create a model which uses and provides us the decision in yes and no. So this is what we will be creating in today's session. I hope you are learning and you are focused on machine learning models and you are practicing. Keep practicing the same data on different aspects also. If today I have taken this neural network, or you can say TensorFlow, you can use TensorFlow in other models also, which looks similar to you, right? You can see whether you wanted to buy this car or not, whether this car has that value or not, by choosing your own inputs. It could include the price, it could include the condition, whether the condition is good or not. So you can create multiple such models like that. All right. So stay tuned with me, and in the next session, let's quickly get started and we are going to create our model. First of all, we are going to look through the data and we are going to understand the data, and we'll see how this data is going to be converted into a machine learning model by using TensorFlow library. So we will be doing that on Google Colab. So quickly get started with Google Colab. So I'll meet you in the next class. Stay tuned and keep learning, everyone. Thank you.